Ooh. Okay, so, sorry, just recording this now. Integration technique, number one, substitution. You can read. It's just easier if we have some methods, and we're going to use substitution here to determine. So in the first one, we replace the 4 theta. We let u equal 4 theta. Take the derivative of both sides, get du is 4 d theta. For d theta, we solve for d theta, get 1/4 du. So we're going to replace d theta with 1/4, which we can move out front of the constant du, and the 4 theta with the u. Do the integral, remember, plus c, and then replace the u, or substitute back for the u, the 4 theta. Okay, second one. And again, we probably could have done this without this method, right? But this gives you something to fall back on. So we are going to let u equal x squared plus 1. Then what's du? Well, it'll be 2x dx. Right? So,
why just the bottom?
Why just the bottom? Because the integral, so if you look at what we have, so let's look at what we've got here, right? We've got the integral of, let's say it's 1 over x squared plus 1, and then 2x dx. So now you can see the 2x dx is just going to be replaced by the du. The x squared plus 1 will be replaced by the u. So this 2x dx, right? This is the same. This is writing out exactly what we've got there. It's just splitting the 2x out over to here and going 1. So now we have the integral of 1 over u du, and we know that one, right? It's just the ln of u, ln of the absolute value of u. So equals the ln of the absolute value of u plus c, and now u is x squared plus 1, so it's the ln of x squared plus 1, absolute value of that, plus c. So what you're looking for is, you're kind of looking ahead, right? It's like, if I let u be the x squared, then when I do du, I'm going to get the 2x, and 2x dx, look, I've got that expression here. So that's just going to be replaced by du, and then away we go. Same thing is going to happen next one. So, well, we're not going to let u equal x, right? So we want u, basically, u is usually the more complicated thing. So u is ln x. So what is du? One over x dx. And if you look, what have we got here? Basically, 1 over x dx, right? Or something over x dx. So this will become the integral. So ln x, that gets replaced by u. Well, u, and the over x dx part is just du. So we have the integral of u du, which is so the integral of u is 1/2 u squared plus c. So this will be 1/2 of the ln of x squared. 1/2 ln x. Oops, needs an x. You'll get no argument with that. Plus c. Which could be written as 1/2 ln squared x plus c. Right. Either notation is acceptable. Huh? The challenge. Oh, the challenge question I think was ln x, just ln x. It's still that we're still not there yet. We don't have the technique. We won't have it for a few more days. So using substitution undoes the chain rule. So if the integral of f of g of x times g prime of x dx, right, if something is in that form and we let u equal g of x, then du over dx equals g prime of x, which means du is equal to g prime of x dx, called the differential. To make sure the power gets to the different differential. We try to choose u to be some function in the integrand whose differential also occurs. Okay, and we end up with this integral simply being a function of u times du. All right, use substitution to determine each of the following indefinite integrals. Which one is this? My numbering is off. Sine theta over cos theta, d theta. Sine theta over cos. Sine theta over cos theta, d theta. Oh, here. This would have been example number 3, but now it's. All right, so what's your choice? So the choice is we're going to let u equal. Well, let's try letting u equal cos theta.
Is this a guess and test thing, or is that like?
No, take a look at it. So what's du going to be? Minus sine theta d theta, right? So notice where we've got the sine theta d theta. Okay. So that means that sine theta d theta is going to be, so negative du will equal sine theta d theta. So now we have the integral of 1 over u. Of course, we got that negative in there too, right? So hang on, we'll put the negative out front. It's a constant, right? Like negative 1. And we've got 1 over u du. Okay, so the sine theta d theta was replaced by negative du. So we'll put the du here. We'll put the negative up front, constant. And we've got the cos theta there, which is 1 over u. So this is equal to negative ln absolute value of u. And what goes on the end? Plus c, which will be negative ln, and now we can replace u with cos theta, so the absolute value of cos theta. Clean that up. Cos theta plus c. I expect we could have let u equal sine theta. I don't know what happened. But. Okay, what's next? 2 plus sine x to the 10th. Okay, what's u going to be? What's the inside function? 2 plus sine x. This is a little bit more obvious of a chain rule, right? Like 2 plus sine x to the 10th, so we have an inner function. Okay, so we let u equal 2 plus sine x. Okay, so what's du? Just cos x, right? Du equals cos x dx. Right? Look, there it is right there, cos x dx. So that's about to become du. And the 2 plus sine x equals the integral of u to the 10th du. Doesn't get much easier than that. What is that integral? So 1/11th u to the 11th plus c. Antiderivative. And then what? You substitute for the u, right? Substitute back in. So we could write this as 2 plus sine x to the 11th over 11 plus c. Okay, or 1/11th. 2 plus sine x to the power of 11 plus c. Man, a lot more stuff moved around. What's this one? Oh, e to the root x. E to the root x over root x dx. So what's u going to be? Nope. Just root x. Because then we'll get e to the u, right? The antiderivative of e to the u is easy. So what's du?
1 half x to the
So 1 over 2 root x dx. Okay, so then the only problem is, yeah, we got that 2, right? So 2 du will equal 1 over root x dx. So now we've got this part taken care of. Right? That's going to be replaced by 2 du. All right, so let's get down here. So the 2 we'll just put up front. We have the integral of what? E to the u times du. Okay, so we've got the 2 and the du, right? 2 we just moved out front. You could have put a 2 du here. You could have left the 2 there, but you could also just move the 2 out front. So there's my 2 du, which replaces this, right? Dx over root x and e to the u. Okay, so what's this? 2 e to the u plus c. And what's that equal to? 2e to the root x plus c. Yeah, I mean, I guess you could actually have said this, right? It's 2 times this, which would make this a 2c, really, right? Which means we could then write 2e to the root x plus some other constant, call it c1, which just happens to be double the original constant. But okay, that.
Is that accepted?
Nah, I'm okay with it. It's, you know, if you multiply a constant by a number, it's just a constant. It's just some constant. Okay, 30x plus 5 times e to the. Oh, here we go. So what's u?
3x squared plus x.
Yeah, so not e to the, just the 3x squared plus x. Okay? Because what's the derivative of that? It's going to be 6x plus 1. Look at this. This is a multiple of 6x plus 1, right? 5 times that. Okay? So we'll be able to get this and this, right? So u is equal to 3x squared plus x. Du is equal to 6x plus 1. Dx. Sorry, yeah. So 5 du will be equal to 30x plus 5 dx. So now this and this gets to be replaced by 5 du. So we can toss down the 5 outside, right? We've got 30x plus 5 dx. This part is du, and then we've got e to the u du. Okay, so e to the power of 3x squared plus x, which is u. 30x plus 5 dx, which is 5 du. So you can put the 5 here, right? 5 du here, then put the 5 out front. So that's 5 times. What? No, e to the, well, yeah, but we got to do the 5e to the u plus c. And then go 5e to the 3x squared plus x plus c. So that might be one where maybe you wouldn't do that as easily without u substitution. Okay, you still might recognize that the 3x squared plus x has a derivative of 6x plus 1, and then recognize that. Right, but this systematizes it. Right, makes it systematic for you, so you don't have to.
Yeah, using your square.
Oh, 3x squared. Yeah.
Oh, 3x squared plus x. Dasha's not here to say it. You're missing the squares, so I have to say it. 3x over the root of 1 minus 3x squared. So what's u?
The one on the bottom.
Is it the root of it, or is it just it? So what's the derivative of 1 minus 3x squared? Negative 6x. All right, so we can manipulate a 3x into a negative 6x, right? If we do the root of 1 minus 3x squared, the derivative of that is a half times over with another root. We can't manipulate that into being a 6x, right? So it's just the 1 minus 3x squared.
Makes no sense.
Okay, so just yeah, bear with me. Okay, so what's du? Yeah. I can't get my bearing. Negative 6x dx, right? So you could see, all right, I want to replace a 3x dx. How am I going to do that? I'm going to multiply both sides by negative a half. So negative 1/2 du is equal to positive 3x dx. Okay, so now I can replace that, right? I can replace the 3x dx. So had you done this, then du would be that, and you go, what do I, what does the du replace it? I don't have any of that stuff in there, right? So this would tell you, go simpler, just go inner function. This is inner function. Okay, so if we just do this, and look ahead a little bit, right? I mean, solving these problems like playing chess, we look ahead a move or two. Just say, if I do just the derivative of the 1 minus 3x squared, I'll get a negative 6x dx. Oh, and I could turn that into 3x just by multiplying by negative a half. So now, what have we got? Well, we got a constant of negative 1/2 that's going to go out front. We have an integral of, now, what do we do for the 3x dx is the, so we've got the negative 1/2. That's the du, so this is just root u. Oh, sorry, 1 over root u, right? 1 over root u. Du. So here's u. That's what's underneath the root sign here. So 1 over u du. The negative 1/2 du gives us the 3x dx. So the 3x dx is being replaced, right? This bit here is being replaced by negative 1/2 du, right? So we put the negative half out front. The thing we're taking the root of, that's just the expression we put in for u. So now we're going to do is the antiderivative of this. So we could write this as u to the negative 1/2 put an integral sign in there. All right, so now we can use our anti-power rule, right? It says add 1, so it'll be u to the half, and do what? And then you got to divide by that same thing. Yeah, so we'll just put a 2 on there, right? So negative 1/2. Okay, so this will be 2 times u to the 1/2 plus c. So negative a half times 2 is just be negative u to the 1/2, but u is 1 minus 3x squared. So yeah, let's just go negative u to the 1/2 plus c, which will be negative root 1 minus 3x squared plus c. Okay, so yeah, maybe this is doable by guess and check, but it's on the tougher end of guessing and checking. So you no longer have to do guess and check. You can just, you do substitution. You do you. Okay, so remember, you're looking for a u such that its derivative, which is going to be some x dx, is replaceable, right? Is, oh, yeah, I can make it, I can make this into this simply by multiplying. I can make this into this, again, simply by multiplying. Now, for some definite integrals, evaluate. because it's happy. All right. What's u going to be?
1 plus 2x to the 3.
Yeah, 1 plus 2x cubed, right? Because then du is 6x squared, and we'll have an x squared dx. We'll just take 1/6 of it, blah, 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 right? Okay, we're going to write it all out. But that's where you're going. If that's u, then I'm going to get a 6x squared. Okay, I got an x squared dx. Having that, I can then carry on. So let u equal 1 plus 2x cubed. Du is 6x squared dx. So 1/6 of du, right? So we want x squared dx, right? Just x squared dx. So we take 1/6. So 1/6 of du is x squared dx. So now we have the thing we can replace with the du. And we have the thing we can replace with the u. So this will be the integral.
1/6 times
Where'd it go? Yeah, sorry. 1/6 times the integral of u to the 5th du. Okay, so 1/6 du, that's replacing the x squared dx. Okay, so that's done. 1 plus 2x cubed, that's replacing u, and it's u, so we've got u to the 5th. 1/6 du, which is 6x squared, is x squared dx. This antiderivative is easy to find, right? So 1/6, no, sorry, it'd be 1/6 times 1/6 u to the 6th plus c, okay, or u to the 36, u to the 6th over 36. Okay, now here's the thing that happens with this. Okay, so we got u to the 6th over 36. Somebody's wrong, right? Okay, so u to the 6th over 36 plus c. Now, we have a choice. You could do this the really, really easy way or the really, really hard way. The really, really hard way would be to now go back and replace the u with the 1 plus 2x cubed, right? So we don't want to do that. Instead, we got to say this integration was over a range from an upper bound of 1 to a lower bound of 0 for x. So if we can find out when x is 1, what's u? Or sorry, when x is 0, what's u? When x is 1, what's u? So now we go a little aside. Let's go up here. So we say when x equals 0, what's u equal to? Well, u is 1 plus 2x cubed, right? So u is 1 plus 2 times 0 cubed. U is 1. What about when x equals 1? Right? So we're looking at the bounds of the integration now, right? This is x goes from 0 to 1. When x is 1, u is 1 plus 2 times 1 cubed, which is 3. U equals 3. 2. It's too thick a line. Just to get a thinner line. So what we're doing is, what we want to work out is u to the 6th over 36, u to the 6th over 36 from upper bound of 3 to a lower bound of 1. Okay. So what we don't want to do is go and substitute back in for x. But if we're going to stick with u, then we have to say, for the bounds of integration for x, we need to change them to bounds of integration for u. Okay, so maybe, let's go over here. We can say it's 1/6. We're doing this, u to the 5th. Okay, so we're changing, so we've kind of worked out what the indefinite integral is, and now we're going to say, okay, but look, if this is the definite integral, right? If we're changing to u, then we're going from 1 to 3. And we know this is u to the 6th over 36. 1 to 3. Okay, we don't need the plus c anymore.
Is that an intermediate step then?
Yeah, well, this is just sort of saying, okay, this time we're working on a definite integral, so here we're going to change the bounds of integration. This was just sort of, well, we've already done the indefinite integral, but now let's go over here. So it's going to be 3 to the 6th over 36. So 3 to the 6th over 36 minus 1 to the 6th over 36. Let's 3 to the 6th. 3, 9, 27, 81, 243, 729. So 728 over 36. Which will be 364. Wow. Will 6 go into both of those? No, 6 goes into 12, so 2 will. Oh, see, I left. On the sheet, I left it at 728 over 36, but it does reduce. 18, what's half of that? 2 into 728. 3, 6, 12, 6, 4, 364. Something over 9, half of that will be 182. 182 over 9. I think. Is it? I just left it. Yeah. Watch your. I mean, and like that's not easy stuff, but people are making like silly mistakes on easy stuff. Like, what's 24 minus 20 and getting 6 or something?
That sounds like me.
Yeah. Just sort of like, yeah, okay. All right. So, what's u going to be? So this time we're going to go over here. We're going to do some work over here. So now we kind of know how we want to handle this. So let u equal ln x. Then what's du? 1 over x dx. Okay? Now we're going to say, hey, now we know we're doing a definite integral. So we're going to change the x value of e to the 4th and the x value of e. We're going to do this over here. So we're going to say when x is equal to e, what have we got? Well, u is equal to ln e, which is 1, right? Ln of e is 1. And when x is equal to e to the 4th, then u is equal to 4. All right, so now we're going to come back over here. We're going to rewrite this. X's are going to be gone. We're just going to have u's. So this problem now becomes the integral from what? Well, so e is on the bottom. So from 1 to 4 of, okay, u is ln x. And we've got dx over x. And we've got dx over x here. Right? So it's just going to be 1 over root u du. Okay, so here's the plan now, right? Having stumbled through the first one. We say, all right, let's go over here. You want to use substitution, and at the same time, because it's a definite integral, let's get our lower and our upper bounds in terms of u. So now we have this problem, okay? And this is what we're going to solve. We're not going to go back into terms of x. We do that for indefinite integrals, right? Blah, 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 u, and then we substitute back in for the u. In this case, we're just trying to evaluate this. Okay, so what do we got? 1 to 4, what is this? It's like u to the negative 1/2, right? So what's that? 2u to the half? Okay, so it'll be 2u to the half. Okay, don't need a plus c, it's a definite integral. Okay, and we're evaluating 2u to the 1/2 on the bounds 4 to 1. which is equal to 2 times 4 to the 1/2 minus 2 times 1 to the 1/2. Which is 2 times 2 minus 2 times 1, which is 3. So all that, it evaluates to
2 times 1 is 1.
2 times 1 is... Yeah, hey. I'm as guilty as you, but
The general
doesn't. Yeah, the generally accepted answer. Okay, look, this is going up on YouTube. I'm not editing that out. It's like that's why I told the group when I did most of the videos was you're here to make sure we get a nice clean set of videos, right? Like that. Me embarrassing myself by going 2 times 1 is 1, whatever.
I may have done that on the test too.
They don't know who I am.
Just kidding. You need to cut this, but as soon as I get to 4 minus 2, I'm like,
Yeah. It's a really, come on, like, merciless? Yeah, merciless.
I thought we would need to use more, so now I have like this like empty like box.
How much is left? Is this it?
Yeah.
Oh, one more, okay.
Look at that.
Yeah, because like she's saying, I don't know how to get through this. A half hour this is going to be sitting around, right? Okay, so, what's you going to be?
Something like pi or a theta or something.
Well, you generally look inside the brackets. What's you?
Theta squared is pi over 2.
Who are you?
Who are you?
You are what? Theta squared plus pi over 2, right? Because the derivative of sine u is easy to do. Also, where does this go? So theta squared plus... Okay, what's du? 2 theta d theta. Okay. Now really what we're doing is we're doing du by d theta, and then we're multiplying both sides by the d theta. But this is just a fast step there. But what do we want? We want 4 theta d theta. What are we going to do?
When we want it?
We want it now. So du is 2 theta d theta, but I would really like to be replacing this. So we can replace 4 theta d theta with 2 du. Now we have to do the balance of integration, right? So we got to do the 0 to root pi. So when x equals 0, this one should be, oh sorry, be theta. When theta equals 0, what's u? Pi over 2. Right? We're just going up to here. We get a nice expression for u, right? So it's easy to change from in terms of theta to in terms of u. When theta equals root pi. So u is root pi squared plus pi over 2, which is pi plus pi over 2, which is what you said, 3 pi over 2. So when doing a definite integral, we definitely do not want to go back to replacing the u with the theta squared plus pi over 2, right? That's for indefinite integrals, right? So indefinite integrals, you do the u, you're going to substitute, you work it out, you get the thing, you replace the u with whatever it was you replaced it with in the first place. For definite, we're trying to work this out. So now this question becomes the definite integral from pi over 2 to 3 pi over 2 of what? Put a 2 in front, right? Because we got the 2 du. As a matter of fact, here, we'll do it this way. Let's take our time. Pi over 2 to 3 pi over 2, and you've got sine u times 2 du. Okay, so the 4 theta d theta got replaced by 2 du. Okay, now we can pull the 2 out front if you like. You don't need to, but 2 pi over 2, 3 pi over 2, sine u du. Okay, so 2 times what? So it's going to be negative cos u evaluated on the interval 3 pi over 2 to pi over 2. 2 times. So it'll be negative cos 3 pi over 2 minus negative cos pi over 2. Throw extra brackets in just for that. You could, but why bother? Right? I mean, it's easy just to evaluate cos of pi over 2 and then take its negative. Yeah. Oh, hey, I didn't take it. No, I did. In grade I didn't take this course. No. When I was in grade 13, which was like university prep, we actually did 3 full-year math classes. It wasn't semester, so we did 3 math classes, 2 science classes, and English. And
Did you go to school in Ontario? Is that
yeah.
why you were grade 13?
Yeah. So in grade 13, I took 3 full-year math courses. Okay, so 2 times. All right, what's cos of 3 pi over? What's cosine look like? Hey, it's like all zeros, right? So it's 0 minus negative 0.
Love it.
It's 0 minus 0, 0, it's 0, 0 plus 0. It's like 0 minus negative 0, which is 2 times 0 plus 0, which is 2 times 0, which is 0.
Honestly, I feel like a Welsh would mark me down if I did it.
There's nothing to this question. Okay, so we got the idea indefinite integrals. Indefinite integrals let u equal du, right? Look what you're aiming for. Du is going to be replacing something dx. Blah, blah with the u, and then you replace the u with what you replaced the u with originally. Go back into in terms of x. Definite integrals. Go look at this one, look at this one. Just go over here, do your u substitution, du, but now take the bounds of integration. When x is, and work out u. When x is the upper bound, work out u. Rewrite the problem. This one's easy to do. This one's not easy to do. Okay, and you're done.
Stop the recording!
Yeah. I'm gonna pause.